You might not run into any triangles like that, but I thought we should mention it just in case. Another thing you might run across is a triangle that already has the base and the height as a part of the triangle. Let's look at this example. In this triangle, we have what we call a right triangle because we have a right angle right in the triangle. And if we decide that we want to let 6 be our base, then if you go to the opposite vertex and try to draw the line straight down, what you actually get is this side of the triangle. So your base and your height in this case are actually already a part of your triangle. So when you go to your formula, 1/2 your area is 1/2 your base times your height. You would just use the numbers right there in the picture. Be 1/2 times the 6 times the 8. And we put 1's under here and then cancel. 2 into 2, 1. 2 into 6 is 3. We're going to end up with 1 times 3 times 8, or 24, over 1. So our answer is going to be 24 square centimeters. You can write the cm squared, or you can write out the word square. Centimeters. But this is just an example where your height is already a part of your triangle. The next figure that we want to talk about finding the area of is a trapezoid. A trapezoid is a quadrilateral that we haven't talked about yet. Remember, a quadrilateral is a 4-sided figure. So we're going to be looking at a 4-sided figure, but in a trapezoid, it has one pair of parallel sides. In this case, these two sides would be parallel. Parallel means they stay the same distance apart all the time, and if you extended them out, they would never cross each other. Notice these other two sides in the figure are not parallel because they get closer together as we're going up, and if we extended them out, they eventually would cross each other. Now, if you have both pairs of opposite sides parallel, you end up with a parallelogram. But in this particular one, we only have one pair of parallel sides, and that's what makes it a trapezoid. A trapezoid is not a figure that you see as much as some of your other figures. Some places I can think of maybe seeing trapezoids, you might remember some desks that you would sit in, like in a classroom in school. Sometimes the desktops are the shape of a trapezoid. You might have one of the surface of a lampshade might look like a trapezoid. Part of a roof might look like a trapezoid. If you thought about turning a flower pot upside down, you might think of what you saw as a trapezoid. But you just don't see this figure quite as much as you do things like triangles and squares and rectangles. But we want to be able to find the area of a trapezoid. And for me to show you where the area formula comes from, what we're going to do is imagine splitting the trapezoid up into two triangles like we did the parallelogram, and then looking at what the area of the two triangles are. So the way we're going to split it up is by drawing in the diagonal again. So let's see what happens. Here you see a trapezoid in which I've drawn a diagonal in and split it up into two separate triangles. And I label those triangles. Triangle 1 is the triangle you see here, and then you see triangle 2. Now, if I put those two triangles together, I would have the area of the whole trapezoid. So I can say the area of the whole trapezoid is equal to the area of region 1, which is a triangle, plus the area of region 2. Now, so let's see about the areas of each of those. Okay, if I wanted to find the area of triangle 1, I need to know a base. I'm going to call the bottom side here the base, and I'm going to call it B1 because there's going to be another base for the other triangle. So I'm going to call that base B1, and then the height is going to come from this opposite vertex, and I'm going to call the height H. So the area of that triangle would be 1/2 B1 times H. That would be the area of that first triangle. 1/2 B1 times H. Okay, for the other triangle, I'm going to let this top side be my base, and I'm going to call that base 2. And then when I get ready to draw the height then, since these two sides are always the same distance apart, the height is going to end up being the same as the other height. Now, if I go to an opposite vertex and try to draw that height then like here, I'm going to have to, this is one of those different shaped ones, I'm going to have to extend this out so I can draw that height up there. And this little line right here will represent my height. But that distance is the exact same distance as the H over here. So I'm going to call this H also. So both triangles have the same height. So the area of the second triangle is going to be 1/2 B2, because we've got base 2, which is the top, times the height. So let's look at that. It's 1/2 B2 times the height. So the area of the whole trapezoid will be 1/2 B1 times height plus 1/2 B2 times height. Now, since both of these have a 1/2 in them and both of them have an H in them, we're going to put the 1/2 and the H out in front and then write in parentheses what's left, the B1 plus the B2. And if you remember when we talked about the distributive property, see, we can say 1/2 H B1 plus 1/2 H B2. The distributive property allows us, if you have a common factor like the 1/2 and the H in two terms, to put that common factor out in front and then to leave what's left on the inside. This particular formula I've come up with, 1/2 H times B1 plus B2, that expression, is easier to work with than the first formula I had. So this is the formula that we will use for the area of a trapezoid. You don't need to memorize the formula because I will give you the formula on a test. Now in your book when you're doing your problems, they won't give you the formula, but you can look it up and get it. But you need to understand what the formula means. Okay, so what the formula says is you need to know what the height of your trapezoid is, and then you need to know your two bases. Your bases are like your bottom and your top here. And to find the area, you're going to say 1/2 the height times the sum of the two bases. So let's look at a trapezoid and try to use the formula. Okay, here's a picture of a trapezoid in which I've given you the length of the two parallel sides, and those are called the two bases. I've given you the 7 centimeters and the 3 centimeters, and I've drawn in the height for you. So we're going to take the formula A equals to 1/2 the height times the expression B1 plus B2, and see if we can find the area. So if I start to fill in things, I have 1/2 times the height. The height is this dotted in part, it's the 5, times base 1 plus base 2. Well, one base is 7, and the other base is 3. So I have 7 plus 3. Now once I fill into the formula, I just use my rules for the correct order and then work it out. Now notice I have multiplying and I have parentheses, and if you remember, we always work inside our parentheses first, so that's what I want to do. I go ahead and write my 1/2 times my 5 but I want to do what's inside the parentheses. So when I do that, I get 10.